Hello, this is an amendment to our Newton-Euler dynamics part 1 and part 2, where I had discussed the solution to the dynamics of a two-link manipulator, or a double pendulum, in other words. Here, if you recall, there were two torques given by the motors tau 1 and tau 2. There is something that I missed here, so I have to add that. Essentially, what I missed is the following. Okay, let me try to explain this. So tau 1 is a torque. Essentially, you can view tau 1 as a torque that is being exerted on the first link by the world, right? Because there is a motor at point tau that is actually attached to the world that exerts that torque on the first link. Similarly, tau 2 here is a torque that is exerted on link 2 from link 1, right? Because again, the motor at point A is attached to link 1, and it exerts a particular torque tau 2 to link 2. But that means from Newton's third law of motion, right? If link 1 exerts a torque tau 2 to link 2, then link 2 must exert a torque minus tau 2 back to link 1, right? So that's the part that I missed in this derivation. So I need to add that, and so I'm going to add it over here as minus tau 2, okay, in this free body diagram. Here I'm writing on the right hand side of the page, tau 2, okay? So if there is a torque minus tau 2 on link 1, of course, that needs to be added to the moment balance equation here on the left side of the page, not equation number II. So I'm going to go ahead and do that, where we have what we have now is plus tau 1 minus tau 2 in the z0 direction here, okay? So if we go further down, where we use that second equation, we'll find it right over here. And of course, over here I need to add the minus tau 2 over here as well, okay? And finally, scrolling all the way down here, all the way down here to the equations Ax equals b, I need to add my torque plus tau 2 here, okay? So now the equations are actually correct. I'm sorry about that mistake that I made, but I'm hoping that the reasoning is pretty clear, where we actually observe that tau 2 is exerted on link 2 by link 1, which means that link 2 must exert a tau 2 back to link 1. Of course, similarly, link 1 exerts a torque minus tau 1 to the world, but the world really doesn't care. We're assuming that the world doesn't move, right? So the long story short, link 1 exerts a torque tau 2 to link 2, which means link 2 exerts a torque minus tau 2 to link 1, and I've added those as the amendment to our Newton-Euler dynamics part 1 and part 2 video series. All right, thank you.